A rectangular tile has length 4x centimeters and width x plus 3 centimeters. The area of the rectangle is less than 112 centimeters squared. By writing down and solving an inequality, determine the set of possible values of x. A second rectangular tile of length 4y and width y plus 3 has a rectangle of length 2y and width y centimeters removed from one corner as shown in the diagram. Given that the perimeter of this tile is between 20 and 54 centimeters, determine the set of possible values of y. So I've got the question here then. So let's have a look at this. The first thing, this rectangle is 4x by x plus 3, and its area is less than 112. So part 1 then. So 4x and x plus 3 is the total area, isn't it, of that rectangle, which is less than 112 centimeters squared. So we can divide by 4 both sides. 56, 28. Half and half again is 28. Tap it in the calculator if you need to. 112 divided by 4. Expand the bracket so we get x squared plus 3x is less than 28. So that tells us then that x squared plus 3x minus 28 is less than 0. So 7 fours then? It looks like 7 fours are 28 and the difference is 3, isn't it? So let's try that. 7 and 4 is less than 0. So here, this is plus, so this needs to be plus, doesn't it, and a minus. So we get x squared plus 7 minus 4 will give us the plus 3x. Minus times plus is a minus. 4 7 to 28, so that's fine. This is a quadratic. So if we did a quick sketch of it, it's a U-shaped curve. And it's got roots at 4. And this value is minus 7. So the quadratic comes down. And by looking at this quadratic, we can see that that quadratic is less than 0 in this range here. So minus 7, x can go up down to minus 7 but not touch it, because it touches it, it equals 0 and it's less than 0. And it can go up to 4. So then, now looking at x, if we go back to our original question, it has length 4x. Now that length can't be negative, can it? So x must be a positive quantity for it to be a length, positive length, which is what we're talking about. So here we need x is greater than 0. So we don't need any negative values from the algebraic solution. So x can go up to, but not get bigger than 4, can't it? And can go down to 0, of course, as the minimum for a positive quantity. So there's part 1. Now let's turn our attention to part 2. So we're talking about the perimeter here, aren't we? And the perimeter is between 20 and 54. So let's fill in all these numbers. That's 2y, this is 4y. So this length here is 2y. This height is y plus 3. This is y. So this height must be 3 here. So let's just add them all up then. Let's go around this perimeter. 2y plus y plus a 2y plus a 3 plus a 4y plus a y plus 3. There's the total perimeter then. It can go up to 54, so it must be less than 54. It's between, so it can't touch 54. It can go down to 20, but it cannot touch 20. So what have we got here then? Let's just take that inequality with us as we go down. Hopefully we've got most of it there. Might drag something with it, but we can always remove that. So this is part 2 then. This is the inequality from the picture. Okay, so that's what we've got then. So we've got 20 is less than 2, 3, 4, 5, 6, 7, 8, 9, 10y. And 3 and a 3 is 6, plus 6 then is less than 54. Take away 4 all the way through. Take away 6 all the way through then. 14 is less than 10y is less than, take 6 is 48. Divide by 10 then, all the way through. 1.4 is less than y is less than 4.8. And we're dealing in centimeters here, aren't we? And y is positive, of course. So y can lie between 1.4 and 4.8 from the picture. That seems fine, doesn't it? There's no hindrance there.